Sorry students, there was a network issue. All of you got the link? Please inform to your friends. Okay, done. So I'm sorry, there was a network issue, therefore new link has been sent to you. Fine? All of you are there? Okay. Still, people have to come, I think. Okay, done. So, I was talking about whatever we have discussed in the last class. And once again, sorry, there was a network issue. So, therefore, new link has been sent to you. Automatically it got off. Okay. Now, when it comes to last class, then we have discussed about methyl, right, which is called as methyl. Then we have another molecule that is called as methylene. We have another condition which is called as methylene. So for time being, you remember about these two. When I am writing the hydrocarbon chain, sir, close the window. It's close only. Okay. Now I have put off the light. Now it's visible. Oh, if I am standing far, I think it is coming. Right? If I go near, it's becoming blur. Okay, fine. Okay. Now I think it's visible, right? Okay. Now when I am talking about methyl, methylene. Okay. So it's like methyl, methylene. Yes, Riya. We'll start with the class. So when I am talking about organic compounds, we have a molecule called as methane. What is this? This is nothing but methane. Methane is an organic compound. It is a hydrocarbon. So it is a hydrocarbon containing CH4 as the formula, right? So it's a hydrocarbon. They only told, sir. It's bright, it seems, for them. That's why I put it off. So it's like we have the methane where CH4 is the formula. Now if you recollect in the last class, means yesterday's class, then I wrote CH3, CH3. So what we did is, we removed from one hydrogen from this particular molecule, then we joined to each other. That's where we got methyl group, methyl group. All of you can see, we have got methyl group, methyl group. So when they are bonded to each other, now it is called as ethane. Now it is called as ethane. Fine, all of you can see? Yes, good morning. Dikshit. Okay, na? So that's why we have methane and ethane. Now observe it carefully. Next, yesterday also we have seen CH3, CH2, CH3. Now which is this molecule? Can any one of you tell me? Which is this molecule? Now just now I have written. Which can be this molecule? Anyone? Yesterday we have discussed about this particular molecule. What is the name of this molecule? Anyone? What is the name of this molecule? Whatever I have written here. CH3, CH2, CH3. Can any one of you tell me? Okay, Ashish telling it as ethene. All of you will agree with him? He is telling it as ethene. CH3, CH2, CH3. Ashish, it's not ethene, it is propane. Ethene means, ethane is an alkane. Ethene will be the alkene. 2 carbon molecules. Ethene, ethane. Alkane, alkene. Okay? So therefore it's not ethane. That's fine, Ashish. No need to delete and all. That's fine. Now we have another molecule. I have written 3 carbons are there. There is presence of 3 carbons. Yes, now people have written it is propane. It should be propane. Okay na? So don't get confused, Ria. It's not methyl pentane. I will come to that. So it's a 3 carbon containing molecule. 1, 2, 3. From here to here or here to here. One and all same. So 3 carbon containing molecule. Here it is 2 carbon containing molecule. And here it is 1 carbon containing hydrocarbon. It's a hydrocarbon. All of them, they are hydrocarbons. Why they are called as hydrocarbons? Because they are having hydrogen and carbon in their structure. So therefore they are called as hydrocarbons. So I have methane, a single carbon containing hydrocarbon. Then I have ethane, a 2 carbon containing hydrocarbon. Then I have N-propane. Then I have N-propane, where 3 carbons are present. 3 carbons are present. Those type of compounds are called as N-propane, a linear, acyclic compounds. Whatever I have written, they are all example for aliphatic compounds. All of you will agree? They are all example for aliphatic compound. Why aliphatic? Because they are non-cyclic. They are non-cyclic in nature. That's 4. Due to their non-cyclic nature, they are having methyl and methyl at their terminal. They are having methyl and methyl on their terminal side. Sir, why we have to write methyl group here? Why not methylene? If I write the methylene, that is CH2, CH2, CH2. If you observe it carefully, whatever I have written, it is wrong. It's not propane. This molecule does not exist. What is the reason? Because carbon is not satisfied. If I observe this carbon, it is having 2 hydrogen, that means 2 covalent bond and another 1 covalent bond. Only 3 covalent bonds are there. But carbon should make how many covalent bonds? 4 covalent bonds. So therefore, this does not exist. You should be very careful when you are writing the molecule structure in organic chemistry. So you should see that carbon should be satisfied with 4 bonds. Okay? So therefore this does not exist. This is the proper one. So please remember, in a hydrocarbon, which is a alkane, a saturated hydrocarbon, then the terminal carbon should be ended up with CH3, that is methyl group only. Okay? And since I have written N-propane, that means I am talking about a linear hydrocarbon, that is propane, N-propane. Because same propane, that means 3 carbon molecule only, it also exists in its cyclic form. That is CH2, CH2, CH2. So this is a cyclopropane. Whatever I have written, it is a cyclopropane. Okay? Now if you observe here carefully, any methyl groups are present in cyclopropane? Any methyl groups are present? There is no double bond, no doubt. In cyclopropane, there is no double bond. All are single bond only. But any methyl group, can you observe there? No. No methyl group, because it is a cyclic structure. There is no terminal. So it is a cyclic structure. They are connected to each other. Right? So therefore, it is a cyclopropane, where methylene groups, they are connected to each other. Yes, all of you right. There is no question of methyl group in cyclopropane. Okay? So therefore there is no proper terminal, there is no end. So therefore it is a cyclic structure. Here there is a terminal, one terminal and another terminal. So it is a linear structure. Okay? Now, what is the difference between ethane and N-propane? Can any one of you tell me? What is that difference between ethane and N-propane? Anyone? What is that difference between ethane and N-propane? Try to understand this carefully, because same things you can study. You are going to study in your hydrocarbon topic also. What is that difference between ethane and N-propane? Just send me the name. What is that difference you can observe between ethane and propane? Okay, fine, very good. Number of carbon, all of you will agree. There is a difference of number of carbon. Here it is 2 carbon, here it is 3 carbon. Now, if you observe it carefully, that extra carbon is because of one methylene group. Extra carbon is because of one methylene group. All of you will agree? So that is the difference between ethane and N-propane. So what is that difference? In N-propane we have one extra methylene group. In N-propane, yes, we have the 3 carbon. Why that 3 carbon? Because one methylene group is present in N-propane. Okay? Now observe it carefully. Next, I will write CH3, CH2, CH2, CH3. Now, how many carbons are there? Whatever molecule I have written on the board, how many carbons are there in that particular structure? It is total 4 carbons. So 1, 2, 3, 4. Total we have 4 carbons. 1, 2, 3, 4. And all the carbons, they are saturated. Yes, they are having 4 carbons. Absolutely correct, Bhumika. So then now this molecule is called as, all of you correct, 4 carbons. So this molecule will be called as N-butane. This molecule will be called as N-butane. Why N-butane? Because on their terminal they have the methyl groups. That means they are having the terminals. They have the ends. So therefore there is a presence of methyl group. So therefore we should mention it as N-butane. Fine? That means same molecule can also exist as cyclic structure. Same molecule can also present in its cyclic structure. That's where it is called as cyclobutane. That's where it is called as cyclobutane. That's where we have the cyclobutane. All of you can see? Hagadre. Therefore, since N-butane is a linear structure, yes, Rohan, N stands for linearity. There is a terminal, there is a linearity. So therefore they will call it as N-butane, normal butane, okay, a linear structure. Now another one is a cyclobutane, which is having a cyclic structure. Now cyclopropane and cyclobutane, they cannot be considered as aliphatic compound because they are having cyclic structure. They can be an example for homocyclic compound. They can be an example for homocyclic compound. Fine? So that's where we have normal butane, normal propane. That is N-propane, N-butane, which talks about a linear structure. Hagadre. Now tell me the difference between N-propane and N-butane. Tell me the difference between N-propane and N-butane. Anyone? What is that difference between N-propane and N-butane? Can any one of you tell me? carbon. Okay, fine. Very good, Ashish. Yes, they differs with respect to number of carbon. Here it is 3 carbon, there it is 4 carbon. Right? In butane, we have the 4 carbons. That's where they differs from the propane. They are having one extra methylene group. One extra methylene group. Okay? All of you have understood? Ashish, all of you have understood? So in case of N-butane, we have one extra methylene group compared to N-propane. In N-propane, we have only one methylene group. But in N-butane, we have 2 methylene groups. So that is the difference between N-propane and N-butane. Okay? All of you have understood? I will write another molecule. CH3, CH2, 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 CH3. Okay? So total how many carbons are there? 1, 2, 3, 4, 5. So total 5 carbons. There are total 5 carbons in this molecule. Okay? And they are having a terminals. Methyl group, methyl group. That means there is a presence of end, terminals. So therefore they are also aliphatic molecule. They are also aliphatic molecule. That means this molecule will be called as N-pentane. This molecule will be called as N-pentane. Okay? Pent talks about 5. So N-pentane. Okay? Now that's where we have the molecule. Now N-pentane can also present as in its cyclic structure. Can also present in its cyclic structure. That's where I have the cyclopentane. That's where I have the cyclopentane. Cyclopentane. That's where I have the cyclopentane. All of you have understood? Any doubts? So that's where I have the cyclopentane, and here we have the N-pentane. Fine. So N-pentane talks about aliphatic organic compound. Cyclopentane talks about homocyclic organic compound. Fine. So that's where. What is the difference between N-pentane and N-butane? N-pentane and butane. What is that difference? Yes, Rohan. They are having 5 carbon. N-pentane, they are having 5 carbon. So what is that difference? They differs by another one extra methylene group. Another one extra methylene group. If I see the N-pentane, I have 1, 2, 3. Total 3 methylene groups are present. Total 3 methylene groups are present. Yes, Ashish, you are right. But when it comes to butane, we have only 2 methylene groups. In butane, we have 2 methylene groups. But in pentane, we have 3 methylene groups. Now, same way, if we go further, we can have the N-hexane. We can have the N-hexane, CH3, CH2, 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 CH3. This is nothing but N-hexane. Okay? Now, hexane can be also present as cyclohexane. Hexane can also be present as cyclohexane. CH2, 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 CH2. So whatever on the right side I have written, it is nothing but a cyclohexane. Right side bottom, it is nothing but cyclohexane. Whatever I have written next to that one, it is a linear structure which is called as N-hexane. So like that, the list will go on. 6 carbon containing linear hydrocarbon molecule will be called as N-hexane. 7 carbon, it will be N-heptane. 8 carbon, N-octane. 9 carbon, N-nonane. Then last one, 10 carbon, it will be n decade. Like that, it will goes on. The list will be going on. If I observe it carefully, from propane, if I start, there is an increment of 1 methylene group. There is an increase of 1 methylene group. So these type of organic compounds are called as homologous series, which you people might have studied in your 10th. They are called as homologous series. So what do you mean by homologous series? Homologous series are those group of organic compound, or to be more specific, homologous series are those group of hydrocarbons which differs from each other by 1 methylene groups. Okay, that's where we have the homologous series, which differs with respect to number of methylene groups. So that's where they are called as homologous series. Any doubt? Any doubt in this? All of you have understood? So that's where we have the homologous series. Please remember, don't ever write N-methane. Don't ever write N-methane. Methane is having only one carbon. They cannot have the cyclic structure. So no need to write N-methane. Don't ever write N-ethane. Ethane is having only 2 carbon. So it cannot have the cyclic structure. So there is no question of N-ethane. But when I am coming to propane, then I can mention it as N-propane, N-butane, N-pentane, N-hexane. Why? Because they are having a cyclic form also. Okay? So therefore, when it comes to ethane, methane and all, no need to write the N-ethane, N-methane and all. It will be a wrong one. All of you have understood? Okay? Now, I have kept these things because we have different way to represent the organic compound. Based on organic chemistry, you will be having a question, where in the question, sub-questions will be there. In that, one question can be represent the organic compound by using skeletal structure or line structure, or represent the given organic compound by using condensed structure. Like that, questions will be there. So you should know how to represent different ways of representing a given organic compound. Now, when I am talking about ethane, whatever I have written, it is the ethane. Now I will call this one as a condensed representation. I will write this one as a condensed structure of ethane. Now same thing, same ethane, I can also write it as CH, H, H, another CH, CH, CH. So what I mean to tell you is, this is also ethane, this is also ethane, no doubt. Both are ethane only. But if you observe it carefully here, I have not shown the bonding between carbon and hydrogen. In first case, I have not shown the bonding between carbon and hydrogen. That's where we can call it as a condensed form. But when it comes to second case, where I am showing each of the linkages by the dash, by the lines, each of the linkages I have shown. So therefore it is called as dash structure. This is called as dash structure of ethane. Okay, what that dash indicates? Dash is nothing but bonding, where we have shown each of the bondings present in the ethane. Now by this I can tell that there are 3 covalent bonds between one carbon with 3 hydrogen, and there is one covalent bond between carbon and carbon. Same logic is applicable for this carbon also. All of you have understood? So that's where we have got the dash structure and condensed structure. In condensed structure, what they will do? They are not going to show all of the linkages. Especially carbon and hydrogen linkage, they will not show. Fine? Any doubts in these two? Okay? Any doubts? This is one way of representing ethane. Okay, this is a way of representing the ethane. Any doubts with respect to this one? Okay? Fine. So, if I take pentane, I am taking pentane now. If I take pentane, now whatever I have written, same thing I can write it in another way as CH3, CH2. How many CH2 are there? 3 are there. So I will write it as 3 CH3. So this is the condensed structure of N-pentane. This is the condensed structure of N-pentane. Okay? Now why we are calling it as condensed structure? Here even these bondings we are not showing, not only between carbon and hydrogen, even these bondings we are not showing. We are writing it as CH2 3 times because we have methylene group 3 times. So this is the condensed representation of N-pentane. Fine? Anything you can write. N-pentane can be written like this or it can be written like that. Both are correct only. Okay? So both are condensed form only. Now if I want to show a dashed structure for N-pentane, then I have to show all the linkages. CH, 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 then 3 hydrogen. So this is nothing but a dash structure, dash line structure of N-pentane. Dash line structure of N-pentane. Can you see the difference? Condensed and dash line structure. So to write the dash line structure of N-pentane, it will consume the time. Now to save the time, I will use condensed form of N-pentane. Now when I have written like this or when I have written like this, in both the ways, people will get the message that I am talking about N-pentane. There is no question of confusion. All of you have understood? So that's where we have the representation. That's where we have the representation. Any doubts? Any doubts with regard to this? This is what we have the representation. Now we have another form of representation, that is line structure or skeletal structure. That is nothing but line structure or skeletal structure. Say for example, once again I will take N-pentane only. Once again I will take N-pentane only. So 1, 2, 3, 4, 5. Now whatever I have written, it is nothing but N-pentane. It is nothing but N-pentane. Okay? So that is with respect to line structure. That is with respect to line structure or skeletal structure. Skeletal structure. Human skeleton. Just like that, we have represent the skeleton of N-pentane. We are not showing the carbon, we are not showing the hydrogen. But when I have written this terminal, that indicates that there is a presence of methyl group. When I am showing this corner point, when I am showing these edges, that indicates that they are representing the carbon, that is methylene group. That is nothing but methylene group. That's where we have the line structure or skeletal structure. Fine? All of you have understood? Any doubts? Any doubts with respect to this one? That's where we have the another form of writing the structure of organic compound. If I want to show the hexane, cyclohexane. So this is cyclohexane, right? If I want to write the skeletal structure, I will just mention this one as like this. This is nothing but cyclohexane. It's line structure. It's line structure. So just skeleton, no carbon, nothing we are showing. So that's what we are saving the time. We are saving the time. So if I write CH2, CH2, CH2 and all, it will consume some time. So to avoid those time, to save the time, we can write it as skeletal structure. All of you have understood? So that's why we have the cyclohexane and N-pentane. Any doubt in this? Any doubts? Okay. So same way, if I have an organic compound, like ethanol, I have organic compounds like ethanol. Okay. In the name itself it is there. Ethanol is a compound made up of ethane plus ON. Ethanol, E will be removed. ಕನ್ನಡದಲ್ಲಿ ಹೇಳಬೇಕು ಅಂದರೆ ಲೋಪ ಸಂಧಿ. ಓಕೆನಾ? ಸಿಂಪ್ಲಿ ಆಗಿ ಹೇಳಿ, ethane plus all is nothing but ethanol, where E will be replaced by OL. That means OL, all, talks about OH group. OL talks about OH group, alcohol functional group. So that means I can represent ethanol as CH3, CH2OH. This can be the way of representing, or CH3, CH2OH, condensed form and the dash structure. Condensed form and the dash structure. Now, when it comes to ethanol, that is ethyl alcohol. Yes, ethanol. Okay. So now ethane alcohol. Okay, fine. Ethane plus alcohol. So that's why we have the ethanol. Now when I am talking about alcohol, all of us we know that carbon and this hydrogen don't have any leftover electron. All of you will agree with me? When I am talking about ethanol, there is no question of any lone pair of electron which will be left over on carbon or hydrogen. All are utilized. Sir, how to write the line structure of methane and ethane? There is no question of line structure for methane and ethane. Okay? So there is no question. Fine, it's applicable for propane. From propane it will start. But for ethane and methane, there is no question of line structure. Okay? Now either I have reached you. They are very simple hydrocarbons. Since 2 and 1 carbons are there, they cannot be represented by the line structure. But for propane, yes, we can represent from propane onwards. All of you will agree? Now, when I am talking about ethanol, as I was telling, carbon and hydrogen, they don't have the lone pair of electrons. But oxygen is having a lone pair of electron. 1, 2, 3, 4. So total 2 lone pairs of electrons are left over. Now if I am showing the lone pairs of electron, wherever it is present, then it is called as Lewis or dot structure. It is called as Lewis dot structure. This is nothing but Lewis dot structure because I am showing the lone pairs of electron left over on those elements where it is left over. I am showing the lone pairs of electron. Now it is called as Lewis or dot structure. All of you have understood? So that's where we have the different way of representing the molecules. Now ethanol, I can mention it as OH. But if I write like this, the confusion here is even OH functional group. Simply I can, if I want to write the OH as a functional group, then also we are representing like this. Then there will be a confusion. So whether we are talking about carbon or simply we have written as OH group. So therefore, ethanol line structure, it will not be applicable. Fine, all of you have understood? So this is where we have the different way of representing the organic compound. So in your exams, they can ask about line structure or dash structure. Okay, they can ask about line structure or a dash structure. That's where you should be practicing. And it will be like organic compound will be given. You have to write the IUPAC name of that compound. Then you have to write the line structure. Then the other questions can be like its property, whether it is aromatic or non-aromatic. Like that, marks will be distributed. 1, 1, 1, 1 marks will be distributed. Then hybridization they will ask. They can ask the hybridization. So like that, 1, 1, 1, 1 mark will be distributed for one particular organic compound. Total it can go up to 5 marks. Okay now? Hagadre, before going for the IUPAC nomenclature, first we should know one particular thing which is called as functional groups, which you people might have studied in your 10th standard also. That is functional groups. Now, in the name itself it is there. So, these are the group of atoms which are going to decide the chemical property of a given organic compound. So, what are functional groups? These are the group of atoms or group of elements, whatever it is. These are the group of atoms which are arranged in a specific manner, will decide the chemical properties, or you can simply mention it as properties, chemical properties of a given organic compound, So that's where we have the definition for the functional groups. In the name itself it is there. They are going to decide the function of a given organic compound. Now what do you mean by functional groups? So these are the group of atoms. That means they are not made up of single atom. There should be involvement of multiple atoms. More than one atom should be there. So these are the group of atoms which are arranged in a specific manner and will decide the properties of a given organic compound. Okay, all of you have understood? So that's where we have the functional groups. Any doubts in this? Any doubts with respect to the definition of functional groups? If you have any doubts, you can ask. Okay? How to write the line structure? Okay. Same question. Okay, fine. So that's where we have the functional group definition. Now if I want to have the examples, now I will go with some of the functional groups. Like we have the hydrocarbon chain, which I will mention it as R. R is not Raghavendra sir. R is the part of the organic compound. Okay. Now that R, it will be attached with a functional group COOH. It will be attached with COOH. Now same molecule we can also represent it as R COOH. anything is fine. Okay, all of you have understood? So these type of structures is nothing but carboxylic acid. Carboxylic acid containing organic compounds. COOH is nothing but carboxylic acid functional group. Okay, now those hydrocarbons or those organic compounds which are having these functional groups will be called as carboxylic acids. They will be called as carboxylic acid. Their name of that organic compound will be ended up with oic acid. Oic acid. Their name will be ended up with oic acid. All of you have understood? So that's where we have the carboxylic acid. In the name itself it is there. They are acidic in nature. They are acidic in nature because they can easily give up the H plus and they can become COO minus. They can become COO minus or COO minus. Either like this or either like this. By removing the H plus. They are the good donors of H plus. So therefore they are called as acid. What do you mean by acid? Which are going to donate the H plus. HCl, hydrochloric acid, they are going to donate the H plus. Sulfuric acid, H2SO4, they are going to donate the H plus. So therefore, any of the compound which is having carboxylic acid as their functional group, their name should be ended up with oic acid. And they are going to donate the H plus. Example, propionic acid, very good. Now, for example, I have CH3, simple molecule I will take, CH3. What is this? This is nothing but ethane. This is nothing but ethane. Okay? Now, observe it carefully. CH3, COOH. Or same molecule I can also write it as COOH. Okay? Now, how many carbon ethane is having? How many carbon ethane is having? Anyone? How many carbons ethane is having? Any one of you? How many carbons are present in ethane? 2. Very good. Now, on the right side, how many carbons are present in the product? Where carboxylic acids are there, how many carbons are there in product also? That is 2 only. Very good. So here also 2 carbon, here also 2 carbon. Right? Both are 2 carbon containing molecules. Now whatever this molecule is there, it is derived from the ethane. Whatever this molecule is there, it is derived from the ethane. So therefore, this molecule, I will call it as ethanoic acid. This molecule, I will call it as ethanoic acid because ethane, it got attached with the carboxylic acid. So therefore, this molecule, yes, Bhumika, it will be called as ethanoic acid. Fine. As I told, name of that molecule should end up with oic acid, ethanoic acid. Okay. So if I see here, ethane, whatever E is there, it is replaced by oic acid. It is replaced by oic acid. E has been knocked out and it is ended up with oic acid. That's where ethanoic acid. Okay, that is the name, scientific name. In general, we can call it as acetic acid. In general, we can call it as acetic acid. That is fine. Acetic acid is the common name, but ethanoic acid is the official name, scientific name. All of you have understood? Anyway, I will stop here. Any doubts? So today we have discussed about carboxylic acid. Okay. Now why their name is ended up with acid? Because they are going to donate the H plus. They can donate the H plus. And the name of those compounds which are having carboxylic acid as their functional group, their name should be ended up with oic acid. Their name should be ended up with oic acid. Okay? Any doubts? I will stop here. Any doubts? Any doubts, Siddhyappa? Okay. So tomorrow we will go with other functional groups. Then we will go with IUPAC nomenclature. Okay? All these things are very important. IUPAC nomenclature. Even for second PU, it will help you out. Okay, now? Okay, then. Thank you. So take care. Tomorrow we'll continue with the class. Thank you.